Hey everyone, it is Tuesday, November 13th, and we've reviewed a bunch of your second draft of the proposals, and I think all the things that we discussed around scope and kind of content and requirements and capture, I think that's really worked because a lot of the content is really good, but what we wanted to do was find a way to give you guys some feedback on the actual structure of the proposals. So we put together a PowerPoint kind of presentation that Bernhard is going to work into a video, so let's just review that together. Okay, so just an outline here really quickly. We're going to start with a mindset for writing excellent proposals. This is just kind of how to set yourself up kind of mentally for this exercise. We'll go through a few kind of foundations for this as a document. We're going to talk about the proposal architecture guidelines to give you guys some high-level structure to follow. And then we're going to talk about a few specific pieces of content that we need to see in every proposal. So this slide deck kind of walks through all the details. I won't pause on every slide, but they're here so that you can go back and pause and kind of dwell on them, see some more details if you feel you need to. So mindset for writing excellent proposals. So let's pretend that you're a small consulting engineering firm and you're bidding on a project with a new client, or another example would be you're a researcher and you're applying for a grant. In either case, you are going to be competing against several other teams, and I think that's really the foundation for this mindset to come up with the best proposal. We're going to be acting as the client, and we will be assessing these proposals, and imagine us kind of discussing the proposals and trying to choose which firm or which researcher to work with or to fund. So a winning proposal will demonstrate a deep understanding of the client's needs, and you can read through, this kind of example text here, but really it's about demonstrating that you understand the problem at hand, whether we're a client or we're a grant agency and we're trying to get a problem solved. The winning proposal will also demonstrate a structured approach to both the problem and the solution. So you could have a proposal with tons of great content and lots of detail, but if it doesn't present a logical approach to the problem, it's just going to be really confusing, and then your client is really going to be concerned that your whole approach will be confusing. It will also demonstrate a command of the fundamentals. So imagine your team submitting proposals with 5 other engineering firms. The one that demonstrates really a good command of the theory and the fundamentals of the problem is going to get the contract, not the one that just lists all this stuff they're going to kind of hack together without any reference to the underlying physics, the math, the engineering, the theory. So really try to keep that in mind. And lastly, a high level of polish and attention to detail. And this doesn't sound like a big deal when you're going to be doing engineering and math and physics and things like that, but it actually really does speak a lot to the quality of the work that you're going to deliver. So punctuation, spelling mistakes, formatting, all that kind of stuff really does matter, and we will take that into account. So some foundations now in terms of structure and sort of theory and the fundamentals, and what do we really mean by that and how is that used. So in terms of structure, you really need to create a logical kind of mental map for all of the ideas that you're trying to convey to your proposal, and you need to communicate that structure and that mental map to your reader. If all you do is provide them a ton of details, the reader is going to lose track. They just have to hold on to all these details. They need a lot of RAM, random access memory, to kind of keep track of all this kind of stuff. And they'll probably end up building their own structure or map in their heads. So if you communicate the structure first, your reader will have this map in their head, and then when they get these details from you, they'll know how that fits in, and they'll have a map for that. And it makes it a lot easier to read, and it's just a lot less exhausting when you're reviewing a proposal. So what does structure actually mean? It can mean a lot of different things, and there's many different ways to think about structure, and it's up to you to kind of pick the right framework, or it could be a combination of frameworks. So it could be major aspects of the functionality of your project or what it is you're trying to build. It could be breaking things out in terms of major subcomponents of your system. It could be critical requirements that the client or the sponsor has. It could be stages of development or the sequence of the experiments that you're going to do, especially if it's a really research-focused project. And how do you come up with structure? So a good way to do this is to use that concept of scope that we've been talking about. So you remember talking about scope as the size of your project, and size implies both the dimensions of the project and how far you're going to go in each dimension. So what are those dimensions of your project? That can give you a lot of hints about the structure. You could talk about, well, there's this dimension of the project, this dimension, this other dimension, and you're going to go through them one by one. That would be a systematic, kind of structured way to explain your project. Again, you can think about the major subcomponents. And you could think about the stages of your project or your experimental plan. So theory and fundamentals. This is really foundational to everything you're going to do as an engineering physicist, and it's going to separate you from technicians and from other types of engineers. So innovation really also relies on an understanding of the theory and the fundamentals. It's pretty hard to do something innovative if you don't have a grasp of the theory. So we're expecting that you will provide an explanation of the theory or the fundamentals that apply to the problem and the solution, so that whole problem-solution space. And this theoretical understanding should underpin all aspects of the proposal. Okay? So let's say you were doing a thermal design project. A bad example would be just saying, well, we're going to use a heater, and it's going to heat things, and we're going to measure the temperature with a temperature sensor, and we're going to use a controller to control the temperature. Like, that's obvious. Right? A good proposal will talk about the physics and will demonstrate a deep level of understanding for how a thermal problem actually works, and that's the proposal that will get chosen. Right? Same with an imaging project. Right? We'll use a camera to image things. Great. Right? Imagine that versus a proposal that really talks about everything that goes into designing some kind of an imaging system and talks about all the physics. Another example would be in testing and validation for any kind of a project. We see a lot of proposals where it just says, we will test this, we will test that, and it doesn't really, have any kind of analysis to explain why a test is important, what exactly is being tested, and a good test plan will refer back to that foundation and to that theory, and that really deep understanding will drive the testing that is going to take place. Okay, so the next section here is proposal architecture guidelines. So there's 4 fundamental things here. There's a rough layout of proposed sections to give you guys some high-level architecture. We're going to talk about the structure and how that fits in, a logical chain of reasoning that ties to the theory, and we'll talk about specific elements of content that we need to see in every proposal. So proposal sections, this is kind of a high-level view, and top to bottom is the order from start to finish. We want you guys to have some flexibility, but this gives you a rough architecture. So obviously start with the introduction and background, then get into kind of theory and fundamentals that relate to the problem and the solution, so that whole kind of problem-solution space. Then talk about objectives and deliverables, and then you get into really probably the biggest part of the proposal, which would be either the designs, which might be for a project where you're really going to build something, or proposed methods if your project is really experimentally based. And then you kind of capture all of that in a plan, and a plan is really something that describes a chronological sequence of events or a flow of events and describes the decisions that you're going to make as you execute the project. So we've got a whole bunch of details here. I'd encourage you to stop and read this. The one thing I will call out is that bolded text and the objectives and deliverables. Really try to make this specific. Try to close your eyes and imagine using your deliverables. Right? I know that sounds a little funny, but it's a really good way to add some specificity to this. And another good way to explain this is to imagine trying to get paid for a contract. You've spent 6 months working on something, you've got an upfront payment, the client now owes you $300,000, you've just handed over what you think are the deliverables, and they think the project's not done yet, and you guys will encounter this in your careers. And the more specifically things are stated, the easier this is going to be. So try to do that, try to close your eyes and imagine actually using this. Does it have a user interface? What's on the user interface? Does it have buttons? What are the buttons? Does it connect to a server? Where's the server? All of those kinds of things. Try to add specificity. Okay, second thing is the amount of structure in various parts of the content. So the intro and the background really doesn't require a lot of structure. That should really be written in a natural way that's accessible to pretty much anybody, and really think about communicating with the CEO and the sponsor's company. But then you really need to pause, and you really need to think about that logical kind of structural approach to the rest of the project and the rest of the proposal. And this is where you really need to break things down and deal with it systematically so that it's not just a bunch of scattered details. And you're going to need to use that structure for the remainder of your proposal, from the theory to the objectives, the design, the method, all the way through the plan. You should have a structured approach. Okay, the third thing is a chain of logical reasoning. This is really important, and it's going to go all through your proposal, through your project, and through your report to your recommendations and your conclusions. Okay, we really want you to start with the theory and the fundamentals and have this chain of logical reasoning that underlies all of the decisions you make, your risk analysis, the tests that you do, the flow of your project, the validation and everything that you do should really come back to the theory and the fundamentals. If you are doing something, it should be driven by your understanding of the theory and the fundamentals of your project. Okay, and the last kind of major thing here is specific pieces of content we want to see. So there's 5 things here. The first is a table of objectives and deliverables. We'll talk about that in a second. A system level diagram, a risk analysis, which should be pretty familiar to you, a project flow chart, which is a new one, and a project Gantt chart. And we're calling this optional because the flow chart is really going to supersede it. We just find the flow chart is a lot more useful when we have so little time for these projects and so many of them running in parallel. And the location of these in this diagram here kind of indicates their position. Obviously we're a bit flexible here, but this is a decently strong suggestion of where they should lie in the chronology of the proposal. Okay, so this is everything kind of captured in one spot, if you want to pause on that. And the next topic is the specific content that we need to see in every proposal. So we'll just go through that again in some more detail. So the table of objectives and deliverables, this is something that we talked a lot about in the first meeting that we had with you guys, and it was really coming from the discussion of the scope of your project. And the scope, again, is kind of the major dimensions of your project and how big your project is in each of those dimensions. And having a table like this where you have, 3, 4, 5, 6, 7, however many it is, major dimensions as rows, and then you have these columns which represent how you're staging your goals. That's a great way to communicate your project and the priorities of your project in a very succinct fashion. So we recommend starting the objectives and deliverables section of your project with that table as a way to kind of outline the entire project. Next up is the system level diagram. So this is pretty straightforward, but it really does help the reader understand things. And this is basically just a diagram that kind of reflects a logical breakdown of your proposed method or your design. It shows major functional elements and subsystems, how they interconnect. It shows information, power flows, material flows through your system or your process, connections to peripheral systems. Again, getting to details here. This should be a pretty detailed diagram, and if there is something that your project connects to or depends upon, it should be in here. Does it connect to a cellular network? That should be in here. Does it access a database? That should be in here. All of that kind of stuff should be in here. It should really be a comprehensive view of your project, and this will be a pretty detailed diagram. It shouldn't have 5 or 6 boxes on here. And it really needs to support the rest of your proposal. The purpose here is that if you give the reader a good system level diagram and something to refer to, and you make sure that all the labels in your diagram match the words that you use in your text, it makes it very easy for anybody reading your proposal to know what you're talking about. It gives them, it really helps to build that map in their mind. Okay, and a new thing here is a project flow chart. So what we found with all the projects is that Gantt charts are good at kind of capturing how things are going to flow in time, but they're not actually good at showing what happens if you run into trouble or what all the stages are of your project. So what we'd like you guys to do is make a flow chart for your project. And this will really indicate how you execute your project, tasks that are done in parallel versus tasks that are done in series. So just to give an example here, this is something we cooked up. Imagine you're making a flowchart for a project that has to do a temperature controller for an application, right? So it's got a temperature sensor, and it's got a temperature controller and a heater, and it's really about making something that has uniform heat. So have a close look at this, but you can see there's quite a lot of detail here. We tried to make it so that it wasn't super vague, but this does convey both how your project will flow, what the structure is, and what the critical kind of time points are. Risk analysis, I won't dwell on this because you guys have done this several times. Refer to the proposal guidelines. It's pretty straightforward. So just wrapping up here, remember that specific content we want to see in the proposal, we need to see a table of objectives and deliverables, the project flow chart, the system level diagram, and the risk analysis. And the Gantt chart is optional, but if you find it helpful, please do include it. And lastly, a deep understanding of the proposal with a structured approach to the solution, command of the fundamentals, and a high level of detail and polish results in a winning proposal. Thank you.